So let's start the session. So please give them a huge applause.
Hi everyone, my name is Nicolas Roard. I'm the tech lead on the design tools on Android Studio and on ConstraintLayout.
Hi, my name is John Hoford. Also work on ConstraintLayout and work on the design surface for Android Studio.
Hi, my name is thagikura. I work for developer relations at Google.
Okay, so before we start, maybe just a show of hands of who in the room have used ConstraintLayout already. All right, so large majority. How many of you are using the layout editor in Android Studio? So don't hesitate to come to us after the talk, and we'll be happy to answer any questions. So let me cover a little bit of the basics of ConstraintLayout, and that should not be too new for you. So first, what is it, and why did we do that? I mean, you all know about layouts on Android, and the way that you create your screens combining those existing layouts. And that works pretty well, but has some limitations, specifically when you take in account performances on one hand, animation as well can be problematic when you have deep nested hierarchy to do your layout. So the idea with ConstraintLayout was twofold. One, create a library that was a separate library, a support lib, because that means that we can actually deliver new versions anytime, which is great for us, but it's great for the developers as well, because that means that you are in control when you want to update to a new version. The second thing is, well, we thought that this constraint system was a more, like a better way of expressing your screens. And more importantly, that allowed us to create a much better design editor, a UI builder, because we could actually really create the library in a relation with the tool. So we could do stuff in the library to support the tool, and vice versa. The tool allowed you, as developer, to do things that otherwise would be very difficult if you were to do it in code or in XML. The other advantage is that we tried to come up with a system that's very flexible, very expressive, so you can more or less do any kind of UI with it without it being necessary to create nested hierarchy, which has, as I said earlier, some implication in performances. So essentially, you should be able to get faster layout, and also in terms of animation, because well, it's much simpler. You simply have a bunch of elements at the same level that you can animate. And as I said, we are developing it fully with tool support, and it's a support lib. It's available mostly on any device. Very quickly, some of the positioning rules, because I hear a lot. Some people are like, "Oh, this seems complex. It's non-intuitive sometimes." And actually, it's very simple. So I think most of you know about RelativeLayout. Well, ConstraintLayout, the basic notion on how to set up your layout is very similar. You just create, you position your widget relative to another widget. And you can see here, I set up that second button. When I move the first one, everything just follows up. So it's very similar to what you already know. There is no magic here. We have this concept of having anchors that you connect to. You got like left, top, right, bottom, and the baseline anchor. But otherwise, it's very straightforward. One thing that's very different, though, is the centering. So if you create two opposite connections, then the widget will be centered, as you can see. And the other thing that you can do is set up a bias. So it can be, it can tend to be closer to one side or the other. So you can think about it as a kind of like percentage-based positioning. And that actually works not just in parent, so relative to the parent, but in fact, in between any type of anchor. So you can have this centering and this kind of percentage-based centering within any anchor. You can do it within 2 widgets or anything. It doesn't have to be just a parent. And that's it. I think the talk is done because that covers constraint layout. Thank you. So there is one last thing, maybe dimensions, right? Because as usual, and that's really coming back with what you know already with Android. You can set up a fixed dimension, like an actual value, 100 dips. You can set up wrap content, essentially ask the widget, give me your size. And for constraint layout, those 2 categories are essentially the same. Like we end up in the solver with just an actual value that does not change. We have this concept of match constraint, and here that's a little bit different. Although if you played with weights in linear layout, that's somewhat similar. So essentially here it's like, hey, I don't know the size. Let the system give me a size. And you can do a lot of interesting stuff with this approach, like supporting ratio and etc. And finally, we do support match parent. We don't like it too much because it's somewhat less expressive. But if you stick match parent, it still works.
Okay. A lot of people don't use the studio's design surface right now, but I'm trying to tell you why you should use it and what's cool about it. So first, let's kind of give you a lay of the land of the design surface. When I say the design surface, I'm talking about this panel right here. It's actually broken down into some sections, and I'll kind of tell you what they are. The palette, that's where you can drag and drop components to create different UI elements. There's a component tree, that's actually the widgets you just created. Whatever their names and certain properties of it will be shown there.
I mean, you can think about it as a representation of your XML.
Then on the right is the inspector. That's actually information about your view. So if you select a view, it'll tell you what is its constraints, if it's a constraint layout, or what are the properties it's set, etc. Then the pure design surface of it, which is the part that you can drag and move widgets around and make constraints. And actually, a lot of the graphics you're going to see today are based on just using the design surface. We have a toolbar at the top that will have a few controls that you can use. And something people kind of don't notice is there's a right click menu, and it is very powerful. So I'm going to go through a few simple operations with the right click menu to kind of give you what it's all about. Here in this case, I'm doing a center, just like the Nicolas showed. It's just simply click, and you notice it's centering against a widget that is not the parent. But you can also do large group operations. In this particular case, we're doing a left align followed by a chain. We'll explain more chains later. But what you're seeing there would require about 20, 30 lines of XML to write, but you can just write it with 2 clicks. And in fact, there are just tons of things under hidden in the right click menu. The nice thing about it is they're actually context sensitive. So if you select something, it'll show you only the operations that you can do with that object. So in this case, you see, oh, I can do these chains, I can make it in a chain, all sorts of things. Now, if that was not enough, we have inference. Inference is kind of a little bit of magic in the sense that you lay out widgets on the screen. If you hit this button, it'll come up with a set of constraints for them that is our guess at it. So it can actually build layouts for you. And you can use it in 2 ways. You can use it at the start of building a constraint system. So you lay out widgets, you hit constraint, and then you don't like something and fix it. Or you could use it at the end. You've done all the ones you really care about, now just finish the rest of them for me. And you can hit the button. I've seen other people use it where they add a new widget, then hit the magic button, and it adds the constraints for that new button. It's very useful for that.
It's also only will apply constraints that it will only create new constraints essentially. So you could just create the constraint that you care about, and for the rest maybe just use inference. It's really a flexible tool.
So another feature we have is the ability to convert relative layouts, actually convert any kind of constraint, any kind of layout. But specifically in the case of relative layouts, it will do a mapping of the actual tags in the relative layout into the equivalent tags in the constraint layout. So you get exactly the same dimensions and properties that you had in the previous one in the relative layout in the constraint layout. But if it's not a relative layout, the same operation will just flatten and do the inference, and that's how it'll get you to a new layout.
Yeah, so for a random layout, the quality of the constraints it will depend on the inference engine sometimes. Maybe, that's not exactly what you want, but for the conversion of relative layout, because constraint layout is essentially a superset of relative layout, it's pretty good.
Okay, let's talk about the performance next. Now, one of the advantages of using a constraint layout about performance. Basically, a view group does measure layout draw when it is drawn. Then suppose you have a layout tree like this. Then starting from the root view group, it measures its children. And it's happening recursively until all the children are measured like this. Then, as you can imagine, the more nested layout you have, the more time is going to be spent on computation. So in Android, it is extremely important to make your layout flattened as possible. Besides that, there are a few caveats with traditional layouts. That is, relative layout measures its children twice, and the linear layout measures its children twice if weight is used. So if you have multiple nested relative layout, the number of measure calls is increased exponentially like this. So which makes things really, really bad. Then suppose we have this type of typical layout. If you build it with traditional layout, you will probably end up with building a layout like this with some nested levels. But if you build it with constraint layout, you can achieve the completely flat hierarchy if you build it properly. Also, based on our observation using the frame metrics API, it turned out the constraint layout is much faster than traditional layouts. So there is an article about this on the Android developers blog. If you are interested, you can go back to the blog.
Yeah, I would encourage you to do that because the article also details how you can measure your layout, and that's kind of the big problem in general with performances. It is highly context dependent, and I would encourage you just to not trust us and verify what's going on in your application. And and this article show you a little bit how you do that and how you use the tool at your disposition. So yeah. Right. So we kind of presented you some of the basic features of constraint layout, and I think you have a good idea of what's going on there. But let's go back a little bit on what we had. So when we released the constraint layout 1.0, we had a bunch of features, like I talked about relative positioning, the center positioning and bias, and a few others. So, if you don't know, some of them are actually pretty interesting. So the gun behavior is something that's actually pretty different than other layouts on Android, where you mark one of your view here, like the middle view, as being gone. Remember, like for the visibility, you can have visible, visible, or gone. And if you try that with, say, RelativeLayout, the resulting layout might not have been what you expected. But with ConstraintLayout, we built it so that it actually, behaves according to specific rules, which are the dimension of the widget get to 0, and whatever margin get to 0 as well. And you see that in that particular example, it works really well. My middle button disappears and everything moves nicely. Sometimes it's not exactly what you want. If you follow the same rules and we mark the first button as being gone, then the margin of that first button goes to 0, and you end up with that, which is not ideal. So we have a concept of letting you specify gone margins, which are margins that will be applied only if the target that you are constrained to is marked as gone. And in that case, well, you can get exactly like what you want. So you can, easily compose a UI and play with this kind of behavior to, very easily have something that can be pretty fancy in terms of behavior, and very easily. Another thing that we have in ConstraintLayout 1.0 is the concept of helpers objects. So those objects are there essentially to let you set up your layout, to create your layout, and not automatically to be there as views. And the typical one that we have is guideline. So you probably heard that before from your designer. They call it sometimes keyline, red line. Essentially, those are the horizontal or vertical lines that designer loves to set up, to create, and to show you what the type of UI that they want to set up. And here, you don't have to think how to translate their guidelines into something. You just create an actual guideline in the editor, and it will set up the right equation for you, and you can constraint your widget to that guideline. We also support ratio, which is kind of nice. If you had to support ratio before, typically it involved like creating your own view group and overriding the own measure and stuff like that. Well, with ConstraintLayout, just actually write down the ratio that you want, and the system will take care of it. We also introduced a concept called chains. So a chain is characterized by having at least 2 widgets like that, and they are connected with bidirectional constraint to one another. Okay, so you see A is connected to B, but B is also connected to A. And we use that to recognize a chain. And what is a chain? It's essentially a way to set up a group behavior to a set of widgets without having to put those widgets into their own view group. And the default behavior, you can think about it as doing something like linear layout, but you can set up different styles for the chains. So the default one is, for example, is spread. So essentially, it will just spread around the available space. And you see there's a couple more. Packed, the one at the bottom, is interesting because essentially it acts like a view group would, but the connection that you would set up from the first widget and the last widget to, say, the parent, you still have the same rules that we're using for the widget about centering and about using bias. So that's a pretty powerful thing. The other important difference with, say, linear layout is that this actually only works in one dimension. So you can set a group behavior like that only horizontally, and your vertical positioning may not have anything to do with this with a group. While if you do that with a linear layout will set both your horizontal and your vertical position. It's not always something that is necessary for your layout, but from time to time it comes in really handy. So when we announced 1.1, we added a couple more concepts. And we actually released 1.1 beta 5 this morning. So if you haven't tried it, I strongly encourage you to take a look. I'd say like the most important concept we added is barriers. A barrier essentially, if you take like this layout, and you see like I got like those 3 widgets and this 4th widget like that. The first 3 widgets, I just want to have that 4th widget being on the right of all of them. But I don't know which one is the widest. It may depend on the language used. It may depend on some content that I'm going to change. So how do you do that? Well, before barriers, you couldn't do anything, and essentially, in that particular situation, you had to resort into putting them into a linear layout. With barrier, you can create a barrier object and reference those 3 elements in the barrier, and then you'll constrain the 4th object to that barrier. So if you take this layout, and let's say that the first text view gets shorter, you'll see that it moved correctly and everything just repositioned accordingly. And you can set up a barrier essentially on the leftmost or rightmost position of a set of widgets, and same for top and bottom. We also introduced the idea of groups. It works a little bit like barriers in the sense that it's an object that can reference other widgets. And you can set up a couple of actions. For now, and we have some ideas to actually do more stuff with it, but for now it's mostly visibility. So that's kind of nice if you have a set of widgets that you want to apply a specific visibility. Before, you kind of had to keep and maintain that list of widgets in your code. While here, you could simply do that in XML, and then from your code, you just set the visibility on group itself. So that's kind of handy as well. And for those 2 elements, groups and barriers, the interesting thing is that those are not view group. So you don't create any additional view hierarchy. You're still very flat, but it gives you a way to still address a set of widgets as a set of widgets. We did also the concept of placeholders, which essentially lets you position an element as a placeholder. You can apply any constraint on that element, and you can then set the content of that placeholder to be any of the other widgets in your layout. And when you do that, we basically remove the original element from where it was and move it to the placeholder position. We also added circular constraints, which is just a fancy way of positioning an element relative to another one, but on a circle, essentially. Example, you can use it in a circular menu, something like that. Andrew Kelly did something that very clearly is absolutely necessary in your application to do, but you get the idea. It's all right. Let's go with a first concrete example.
Okay. Then, as Nicolas explained, the ConstraintLayout is able to cover the wide range of layout types with these features we explained. Then let's take a look at how this can be used in a typical layout. Then this is the typical layout in Android we have. And this is built by using ConstraintLayout. This is the blueprint model. Now,
and actually, we didn't talk about the blueprint mode, but that's one of, in the designer, you can have either the design mode that will show you what your application should look like on your device, or the blueprint mode, or actually you can have both at the same time. And the idea with the blueprint mode is that it removes all the elements. For example, it won't show the content of an image, but it will show you all the rules. And there's also various settings you can activate to determine what exactly you want to show in that mode. But think about it as, well, that's a mode to help you just set up the constraint. So if you don't know about this one, again, give it a try. It can be way easier to set up things in that mode.
Okay. Then let's take a look at some widget, how this can be achieved by constraint layout. If you look at the image view at the top of the screen, the width of the image view is expanded as the same width as its parent. So in this image view, we set 0 dp, which means much constraint. And we made horizontal constraints that are connected to its parent. So that means the width of image view is expanded the same width as its parent. Then if you look at the middle of the screen, there are two text views. And the left text view is vertically aligned relative to the text view on the right. And how did we achieve that? We made a baseline connection from the left text view to the baseline of the right text view. Then, as a result, the left text view is aligned vertically. Without using constraint layout, probably you would end up with wrapping these text views with a new view group. Or if you look at the bottom, there is a text view that is centered horizontally. In horizontal direction, there are two constraints that are connected to its parent and with no bias. With no bias, it means it is centered horizontally. All right.
So one of the things that we introduced in 1.0 was the concept of constraint sets. A constraint set is a container for all your constraints that is to be applied to a constraint layout. And so it allows you to now manipulate it programmatically. So it actually has a programming API, and that allows you to set constraints and get constraints and modify the values in it. But it also has an XML form for constraint sets itself. So if you actually wanted to write it separately as an XML, you could. But most of the time, you initialize them in one of two ways, but there's the XML way as well. You can clone off of an existing layout file. So it doesn't even inflate the file really, it just reads the file. Or you can create a live layout and you can clone off the live layout, assuming it's a constraint layout, obviously. So how do you apply it to a layout, a constraint layout? You just call constraint set dot apply to and the layout. And it will essentially delete all the constraints on the constraint set, on the constraint layout, and reapply all the constraints on the new constraints. So let's go through how you would actually use this. During some sort of initialization or setup, you would create a couple of constraint sets. Then during your onCreate or at some other point when you have your hands on the layouts, you can clone both of them that you want to have. So now you have constraint set 1 and constraint set 2, and they have the constraints on them. And then at some point you need to change, you can just say constraint set apply to, and it'll change it to the new one. Now, one of the cool things, thanks to Chet, you can use begin delayed transition, and it'll automatically animate between the two. So you get this animation for free between one constraint set and another constraint set. And the other thing that's kind of cool about when you set up an animation like this is that the two states of the UI can be in layout files. So that means you have access to XML layout for both animations. So in this particular case, I create two animations. In this particular case, I create two animations, and these are done with layouts in the GUI builder. I laid out everything correctly, and I can change them anytime I want, and the animation will animate between the two of them without any changes to the code part. And here's another example of that. In this particular case, I'm going, you hit a button, it adds the text field in it. It actually gets pretty intuitive, and it allows you to have the design of each of them sort of separately, yet get animation between the two of them.
I mean, the other thing to realize is that because we are simply changing the constraints, none of the views in your view hierarchy are reinflated or anything like that. Essentially, your objects, your views are already there, and we just like we apply different rules. So it's basically gives you a lot more power in terms of when you want to pay the cost of loading those things, but in terms of applying them, it's kind of free.
Okay. Then let's take a look at how constraint layout is used in the real-life examples. Now, one of the great things about the constraint layout is it can almost replicate the features provided by the traditional layouts, such as linear layout. The basic usage of linear layout is a flowed behavior like the image on the left. So if you replicate this behavior with constraint layout, is basically simply you make a constraint from a view to another, then iterate the same thing, like the video on the right. It's simple. Then another thing about another common use case of linear layout is weighted behavior, like the image on the left. If you want to replicate this behavior, then you can create first a vertical chain, like the image, like the video on the right. Then you can click the top edge of the light inspector, like the video. Then you can change the layout height as much constraint. Then the view is expanded. The view takes available space. Then you will get the same effect as the linear layout and the weighted linear layout. The next example is percent layout. There is a layout called percent relative layout, where its children, the size of its children can be specified as percent. Constraint layout can also replicate this behavior. Also, the percent relative layout is now deprecated. So anyway, you should use constraint layout. This can be done by using a guideline. First, you create a guideline and size it with percentage and add constraints from a view to the guideline. Let's take a look how this can be done. As I said, first create a guideline. Then toggle the guideline and position it with as percentage. Then put a view and make constraints to its parent and to the guideline. Then change the layout width as much constraint. Then the size is expanded. We apply the same thing to the second view. Then you will get the same effect as the percent relative layout. Okay, this is example of real production app. This is a Google Thunder Tracker app. Google releases annually around Christmas. This is the main screen of the Thunder Tracker. Last year's Thunder Tracker, there was a requirement that the number of items in each row should be determined by the size of the screen. Like this. Then we decided to use recycler view for its container. And we used the Flexbox to determine the width of each item. But we still keep the aspect ratio of each image. So we use the ConstraintLayout to wrap each view folder to keep the ratio of each image. This is the actual XML used for the view folder. As you can see, the root view ConstraintLayout is as root. And the constraint dimension ratio is specified in its image view to keep the ratio. Without using a ConstraintLayout, probably you would end up with creating a custom view. And its height is determined by the determined based on its width. But by using a ConstraintLayout, this kind of custom view was not needed. That was fantastic. Another case is the last year's Google I/O app. In its feed screen, there was a nice animation. By clicking the title of each feed, the image is the size of image is alternately expanded or collapsed, as you can see. Then how did we achieve this animation? Basically, we prepared two layouts that represent the collapsed one and the expanded one. And we prepared two constraint sets and loaded the constraint sets from the layout that represents the collapsed one and the expanded one, respectively. Then we use a transition manager to let it do the transition between the constraint sets. Then we toggle the states alternately by every click. Yeah, that is how we achieved the animation in the Google I/O app.
Yeah, and as John was explaining, like because you essentially can create those constraint sets out of existing layouts, it gives you all the benefits of the layout editor to create those two states of your animation. So it's very easy to create animation like that, or at least it's easier than it used to be. Let's cover some tricky layout that maybe you found or you had similar issues, and sometimes like the answer may not be as intuitive as you would think. So you can have this type of situation where you are creating a layout that represents a row, let's say in your recycler view. And that sounds fine. You can create that pretty easily with constraint layouts. You have a bunch of widgets connected to one another. It's all this world relative positioning that we talked about. Nothing fancy here, but there is one issue. If the title gets very long, you'll see that it's basically going to overlap with that number at the right. So one way to fix that is to essentially create a constraint between the title and that number on the right. And because at that point you will have two constraint opposite, one on the left for the title and one on the right connecting to that right element. You will also set the bias to 0, which means that it will be all tacked to the left. If you do that, everything will work with one little thing. You also need to add constraint width equal true, so that we'll make sure to respect the constraint in that case. And then everything will correctly wrap. So it's pretty common use case, and that's kind of the thing with constraint layout. You have a lot of possibilities on how to combine all those different features, and some of them, yeah, it's not as intuitive. Another example where you may want to have those two elements, and if the text, like those 1 and 2 elements, and let's say that that element 1, that first text view grows, and you want it to grow up until basically the maximum of the screen, well, you can use a similar trick. You can create a chain, horizontal bias of that chain to 0, and again apply constraint width. So the reason we use constraint width like that is you would set the dimension of the text view here to be wrap content. But for efficiency reason, when you simply set wrap content on that text view, internally, we'll consider it as a fixed dimension. That's fine, and most of the time that's what you want, other than when you want that dimension to potentially be overridden by the system. So that's where using constraint width or constraint height like that, adding this equal true, applies. In that case, the system is going to override that dimension if need be, so that the constraints are respected. The reason why we don't do it by default is simply because it's actually not that, it can be costly in some situations. You end up in similar things where you do the measure twice, like with linear layout and 0DP. It's the same issue. So most of the time you don't need it, but in some situation like that, it's pretty convenient. Another thing that some people don't realize, that we've been talking about constraint layout and saying like, yeah, it's great, you can create flat layout, it's awesome, and yes, that's true. That doesn't mean that you don't have to use components. I've seen some example where people just basically create their entire application as a flat screen, and yes, technically you can do it, but at some point you also have to ask yourself, is that the right way in terms of modularity, in terms of maintenance? I mean, for me, I think constraint layout is better used when you think about it as within a single component, the entire layout can be done with constraint layout. But that doesn't mean that the entire screen can be done that way. You can still compose components. And actually, one example like that is simply to use constraint layout within a constraint layout, and you can easily do stuff like table-like positioning that way. So don't forget that you can still use components. It's okay. It's not horrible if you use a linear layout in a constraint layout, for example, depending on what you mean. Something else is, because there is advantages with constraint layout, some people are like, yeah, let's convert everything. And I'd say, sure, but also, it doesn't automatically make sense. If that's the only thing you have to do, yeah, knock yourself out, re-implement everything in constraint layout, that's not a problem. But if your application works and you don't have performance issue, and essentially, your screen is not going to change, leave it the way it is. It's not going to break. To me, I would say like the rule is essentially if you are creating a new screen, at least consider constraint layout. Or if it's a screen that is going to change, or may need several back and forth between UX, your UI designer and your programmers, yeah, okay, sure. But otherwise, if you have an old screen that was perfectly fine, maybe there is more important stuff in your application than reinventing the wheel. Another item is that, yes, chains are very powerful. You don't have to use them either. There is a lot of situations where you could actually achieve the same results with simple relative positioning. Chains are a little more costly than the simple relative positioning, so keep that in mind as well.
Okay, we'll go through this really quickly.
It's okay.
Custom components. Now, one of the things you can use ConstraintLayout, if you've built custom components in your UIs, so you might say you have a team that designs your calendar widget or something like that, you can consider ConstraintLayout as a tool to be used inside of your custom components. So you can do it by just extending ConstraintLayout. Obviously, by doing that, you've encapsulated the behavior within that, but you're using ConstraintLayout, so you get all the benefits of the GUI builder and all that stuff. And we'll kind of walk you through a little example here. So let's say you decided this behavior is a behavior you like and you want it to be used often. And we saw other cases where people were using it. So it's animated, it has a particular layout to it. So you end up in a kind of weird UI if you don't use constraint layouts. And let's not get into that. But if we are actually using constraint layout, you can actually do exactly what I talked about before. Build two constraint sets, create a toggle API for it, and change the constraint set. So these are the two layouts you defined. And then this is the entire class written in Kotlin.
If you ready to components.
Huh?
Yeah, so if instead of doing that as a screen, you write it instead as a component, you end up with something more like that, where you can really easily with Kotlin create a subclass of constraint layout and set up the constraint set in your init, and that's it.
It's very simple. And we'll just say you set it up, you grab the constraints, you create the constraint sets, you have the on-click toggling between them, and in the on-create you load up the constraint sets. So,
all right. Hopefully that this talk gave you like a little bit of a good overview of where we are right now with constraint layout, and essentially it's a very rich ecosystem where you can do a lot of things and often in a lot of different ways. But in terms of what we are looking forward, what the next versions of constraint layout. First, we are still very concerned or very interested into improving performances. And in fact, that's actually one of the really nice things for us. Because it's a library, we will continue to improve it to increase the performances. So normally, if we manage to do it right, next versions of constraint layout will be even faster and faster and faster. So that should be good for you. The other thing we want to work on for constraint layout 2 is a notion of having virtual view groups, using a little bit some of the principles of the barriers or the groups that I talked about a bit earlier. But here, for example, to set up a chain more easily, we have some other ideas with layers or table-like layouts that you could do it that way as well. Flexbox layout like behavior too. We have a concept of decorators that's kind of, taking again this idea of having an object that can reference to the other object without it being a view group. But this time that would also be a view, and that can be interesting when you have a view whose drawing depends on other widgets' position, for instance. So you could, we'll go more into that in the next few months, but we'll have a lot of interesting ideas. And in general, Constraint Layout 2, as Constraint Layout 1 and 1.1, is going to be developed hand in hand with the layout designer in Android Studio, and we'll have more tooling. Really the key here is that we want to provide you a very efficient tool for you to really save time. We also are working on some interesting new things that hopefully we'll be able to demonstrate at I/O. And that kind of concludes this talk. There is way more documentation available online. Here is a set of common links. There is a ConstraintLayout.com website that's been set up by the community. There is the developerandroid.com pages that contains documentation about the current API and etc. So have a look. This and there is way more, of course. And that's it.
Thank you very much.